Hi, mathematicians. This video is going to really kickstart a lot of our work that we're going to be doing with factoring and factoring polynomials. So a couple refreshers before we go. It's just a reminder that factoring really just undoes or reverses multiplication of the distributive property. And then second, the goal of any factoring for a polynomial is to take a polynomial written in standard form, addition of monomials, into a polynomial that's written in factored form, multiplication of polynomials. So keep that in your back of the mind. That's our goal. Now, the first step always when factoring is to try to factor out a GCF, looking to see if all the terms in a polynomial have a GCF that can be factored out. So here we're going to start by factoring this polynomial, looking for the GCF and factoring it out. And we're going to do it both algebraically and using an area model. Because we already have the polynomial in standard form, that's the area, the inside of this. And now we want to find the side lengths, the multiplication pieces. Remember, we're reversing. So we're reversing the process of finding an area model. I'm going to scroll up a little bit. I know my photo sometimes hides things, so I'll be more mindful of that. I'm going to start by taking the three terms in my polynomial and finding their GCF. I'm going to do a little factorization. You know, I'm not going to do the prime factorization here because I see right away that 24, 36, and 12 share that common factor of 12. So I'm going to write them now as this is 12 times 2, and I am going to expand out my variables. 36 is 12 times 3, and I've got x squared, and this is 12 times x. Let's go through these and look for our factors in common. They all share a 12, and they all share 1x. So I know my GCF is 12x. And this is really cool. This means when we're going to factor out that GCF, the 12x is one side of my area model because it's one factor. Now, to help to see what the other factor is, I'm going to rewrite each of these terms as a product of our GCF. You already had practice with this, so this should feel super comfortable. So 24x cubed is the same as 12x. Excuse me, don't forget that x. 12x times the factors that are left over. 2 times x, 2x squared. And we're going to add to that our GCF, 12x, times the factors that were left over here, 3 and x, 3x, plus our GCF times, okay, wait a minute, alert, we have nothing left over here. What do we put there? Aha, this is where we put 1. Remember, any number times 1 is itself. So this is the same as 12x times 1. Okay, here's our common GCF. It's one side of our area model. We can now factor that out. We're working the distributive property backwards. We're factoring it out. And what's left inside are all these other little pieces. 2x squared plus 3x plus 1. But see that on the area model? That means this would be 2x squared, 3x, and 1. And we could always double check if we factored correctly by going again the other direction. Let's distribute. Let's look at the area model. Does 12x times 2x squared equal 24x cubed? Yeah. 12x times 3x, 36x squared? Yep. And 1 times 12x. And so we know we have factored out the GCF. All right, mathematicians, time for practice and lots of questions. See you soon.